In each chamber, there's something different happening to the effluent. In chamber number 1, it's being treated just by nothing more than what we call anaerobic bacteria. That's bacteria that likes to live in a system where there's not much oxygen. From that point, the wastewater goes into the second chamber where it's treated with aerobic bacteria. And those bacteria like to live on highly oxygen-rich systems. So we pump oxygen into that second chamber to feed that bacteria, which causes them to get active and do the work in the second chamber. As it moves to the third chamber, we call that the clarification chamber. When the effluent gets to the third chamber, basically what you have a settling out. You have stuff that doesn't quite get treated float to the bottom, and you get kind of some oils and greases that float to the top. From the third chamber, water goes in two different directions. The stuff that didn't get treated properly the first time goes back into the first chamber, where it starts the process all over again. The water that is clean and clear gets pulled out of the middle and put into the fourth chamber. From the fourth chamber, it'll eventually go into the field. One of the bits of magic that really makes this tank efficient is the fact that we're taking bacteria out of chambers 1 and 2 into chamber 3, and then we sort of mix them all back into the previous chambers again. And what we get is a cross-pollination of different types of bacteria that eventually do battle with each other. And the way they fight each other is they need to consume particles or food. What we call waste or effluent is actually energy for them, and they consume it so they can fight each other and sort of do battle with each other. And that's the real secret here, is all that's happening here is it's natural. It's just forms of bacteria doing what bacteria do, trying to take over each pod, and they fight like crazy. By the time they're finished fighting and they've consumed all the materials, all the raw material out of the water, that's why we're left with such a clean, clear, almost odorless wastewater that when it leaves this tank, it'll be so clear that I could literally probably put a glass of it on your kitchen table and you may drink it by mistake, and it probably wouldn't hurt you. Once the water leaves this tank, leaves the fourth chamber from the irrigation chamber, we then distribute it. This is a sample of the subsurface drip irrigation piping that we use. You can see on the bottom it's got a small hole. What happens is the treated water goes into this pipe and is pressurized, and water will come out. If we look at a cutaway section of the pipe, we'll see that in the pipe we have what's called a dripper, and this little apparatus here basically picks up the water as it travels through the pipe and will take it through a system of grooves and chambers, and will eventually let it go out and into the ground. This dripper is designed as a gateway to only allow a certain amount of water to go through on a certain very specific time schedule. And what it is designed to do is to deliver a certain amount of water to a square footage of ground, and only enough water so the ground can handle it and not over soak it or oversupply the lawn. We're very excited to be in the Naramata region. This is our first install for Naramata, and we normally stay put in the Fraser Valley area where our home base is, and we hope that this will be a solution for many other residents in this area. We've also gone to great effort to make this a very cost-efficient solution to residential wastewater. Typical fields done in the old style here in British Columbia can be much more expensive, almost 2-3 times the cost of what we're able to put together here. By using new technologies, and I'll just explain new technologies. What we're doing here today and what you see behind me is actually not new technology. This is the way they do residential wastewater treatment in many other areas of the world. This tank you see behind me, there's probably about 30,000 of them in the country of Australia. They actually make them out of concrete. We use the iso-resin fiberglass here because it's just more practical for our area. The subsurface drip field that we put in is quite common throughout the United States, and the technology was developed in Israel, and they used quite a significant amount of it for irrigation and residential wastewater treatment. And so what we're doing here is not anything new as far as technology is concerned, but it's very, very new to British Columbia. We believe that this is a far superior product as far as environmental impact goes. traditional systems have been all about disposing the wastewater once it goes through whatever level of treatment that has been established in the past. Typically, or in the past, the water has been partially treated in the first process of the treatment center and then put into the ground 2, 3, 4, 5 feet underground. With the concept was to basically dispose or get rid of the water and make the water just go away. What we're doing here is quite a bit different. We don't want to make the water go away. We want to use it. We want to recycle it, and we want to recycle it in a way that's environmentally friendly. What happens with this water once it leaves the system behind me? The only real problem with it from this point on is it's very high in nitrates and it's very high in phosphates. Now, by putting that water at a level of around 12 inches below the surface, we allow that to be used by plants, shrubs, trees, all of course which use nitrates and phosphates as part of their growing process. So it's more of a dispersal as opposed to a disposal system. And by dispersing the water to where it's needed, it gets 100% used on site, on location, and we're not trying to send it in any direction or dispose of it in any matter.